Hello everybody, this is Rudra Pradhan here. Welcome you all to BMD lecture series. Today we will continue predictive analytics and that too dummy modeling part 2. So, in the last lectures we have discussed this dummy modeling concept and that too we are going through predictive kind of structure where one or many independent variables may be categorical in nature. But again in real life scenario you will find plenty of managerial problems or business problems where you will find dependent variable structure will be categorical. So, as a result your the kind of predictive structure will be very challenging and again it will be also more interesting like dummy independent modeling. So, dummy dependent modeling is also very interesting kind of structure through which you can actually go for hardcore management kind of decision and then the kind of management predictions, right. So, in order to know detail about the particular structures, so let me start with the kind of discussion today. And in the dummy dependent modeling structures we like to focus on three things, and typically there are three different models which we frequently use in the kind of dummy modeling, that to dummy dependent structure, that is called as linear probability model, logit model and probit model. So, all are more or less same, but there is a kind of structural kind of structure through which we have to actually understand and then connect as per the problem requirement. So, the linear probability model is nothing but actually is a kind of linear regression modeling, and logit and probit is a kind of cluster called as nonlinear regression modeling, and that too in a kind of dummy setup. So, so these are kind of structure through which we have to discuss. So, let us first understand the dummy dependent structure altogether. So, most of the cases either it is a binary representation like failure, success, yes, no, true, false kind of situation, and in that context we use a kind of probability model, and that too it is called as the linear probability model, or sometimes it is called as binary choice model. And some in some occasions the dependent variable structure may be categorical. So, that means it may have the option of more such kind of categorizations. So, now in order to know the kind of details, so let us see here, so how is the kind of predictive structure or the kind of modeling structures when the dependent variable structure will be a binary or some kind of categorical. So, accordingly, so we have actually a different structure altogether, and this is the complete structure of dummy dependent modeling. We start with actually qualitative dependent structure, and that too dependent variable structures we are not highlighting here, because we are strictly focusing on dummy dependent modeling. And in the binary dependent it can be with respect to quantitative independent and with respect to qualitative independent. Then accordingly in the case of quantitative independent it will go with logistic regressions or probit regressions, which is our actually today's discussion. And in other sides if it is a qualitative independent, then this will go with log linear models. And again in the categorically dependent it may be with respect to quantitative independent or with respect to qualitative independent. In the case of quantitative independent it can be with multinomial logistic, or it can be go with discriminatory analysis, but in the case of qualitative independent it will go with log linear models. Again in the case of ordinal dependent we have actually two options, and that too it may be with ordinal logistics or it will be with log linear models. So, that means actually the kind of dummy dependent modeling we have actually plenty of different structure through which you can do the kind of modeling and do the kind of predictive structure as per the management requirement. So, by default after looking this chart we can understand that this has lots of utility or flexibility to and that is highly required for the kind of management or the kind of business environment. So, let us see how is this particular dummy dependent variable modeling structures, and then we will connect with some of the sample problems. And this standard model start with dummy dependent modeling is called as a linear probability model, and in that context, so your y is nothing but called as p, and I can actually write here y equal to simply alpha plus beta x plus u. So, this is actually the original model, but here every times y will be in between 0 1. So, that means, so the variable the problem will be in such a way that the y information will be in between 0 and 1 only. So, that means either yes no or something kind of like male female kind of situation. So, it is only vary between two kind of alternative situations, and then it will be predicted with some of the independent variables. So, now the particular modeling structure connected with probability, and as a result we have actually three different models altogether. This is a linear probability model, otherwise called as a binary choice model BCM, and then we have a logit model and probit model. So, now so let me first connect with this linear probability model, and this is the sample case. And so, the since it is a linear kind of modeling structure, so the kind of prediction will be a more or less straight line, and which is actually slightly different in the context of logistic regression modeling. And the logistic regression modeling, the typical modeling framework is a log of p by 1 minus p, which is equal to alpha plus beta x. So, that means technically earlier case it is p equal to alpha plus beta x, here log upon p by 1 minus p, that is actually called as odd ratio, and which is actually ratio between probability of success to probability of failure, and that need to be predicted with the independent variables, and that is what a little bit more advanced and little bit more complex compared to linear probability model. And this is followed by logistic functions, and technically so the y variable is not means technically p is nothing but 1 by 1 plus e to the power minus, that is what the logistic function altogether. And so the usually the graphical if you go by graphical plotting, then logit model behavior will be like this, it follows a logistic function altogether, compared to linear probability model it is a straight line equations, right. So, only thing is actually you have to check whether the particular model is fitted under this problem kind of situation or not. So, we have to first check and then apply as per the requirement. However, so interpretation of logistic regression model is not so straightforward, because the effect of a independent variable on dependent variable is statistic, means technically it is a similar kind of testing procedure, but the interpretation is slightly different. Directly you cannot use like usual procedure of OLS estimations. Here the kind of interpretation depends upon odd ratio, which is nothing but p by 1 minus p. So, after doing the transformation, when you will get the estimated values, so what we can do actually to get the odd ratio, you find out e to the power that particular estimated coefficient, then that will give you the component of odd ratio. So, having higher value of odd ratio, particularly greater than 1. So, the prediction will be more likely to happen, and if it is less than 1, it will be less likely to happen. So, this is how the interpretation side so far as logistic regression is concerned. Otherwise, the kind of structuring, the kind of estimation process. So, what will you do actually in the Excel, you can do the kind of operation, and as usual you can estimate the kind of models, or else you can go to the particular software and give the option about this the typical models. So, automatically you will get the estimated output. So, so that means technically in the kind of logistic structure, it is the odd ratio which give you the model structure about the kind of means it is a kind of prediction structure and the kind of interpretation. In the kind of multivariate structure, so this is the same framework, but we can add one after another variable, and in this context, so this is actually one variables and followed by followed by this is another variables, and this is a interactive effect. But it can start with a single variables, or it can go with multiple variables. So, it is not a issue, but the structure is more or less same. Only difference is only the kind of right hand side part. So, whatever dependent variable information you have, that will be converted into this particular format. Then after that the estimation process will be more or less same, and while interpreting, so you have to take care the structure of what we call as odd ratio. So, likewise you can actually refresh this one. So, this is actually what I have mentioned earlier, the kind of logistic function, and the same model which we can actually put in a different way, where probability of x can be predicted with 1 plus 1 by e to the power minus z, means if you rearrange, then the model will be can be written like this. Okay, so, this is what actually the kind of logistic structure, and let me highlight with a simple example. And this is a kind of example here, bank loan problem issue, and when somebody will apply for the loan, so it may be approved, it may not be approved. So, now we have a spreadsheet, and where we have a plenty of data, out of which some are approved case, some are not approved case, and it is actually predicted through couple of independent variables, and your dependent variable is actually loan approved or not approved, that is yes no type of things. So, if it is approved, then yes case we will put 1, and no case we will put 0, and it is predicted with independent variables, that is return on assets, net income as a percent of total assets of a particular applicant, and debt as a percentage of total assets of that applicant, and officers who is in charge for handling this kind of loans. Okay, so this is what actually the kind of problem background, and then again we will see the kind of output compared to the kind of linear probability model and the logit model, and this is the linear probability model output. And as usual, actually, since with respect to this we have a spreadsheet, just you have to connect as usual regression structure. So, by default you will get the output, and here the kind of assets is coming actually positive, and the debt part is coming negative, and the officer in charge is coming actually negative. So, as a result, but but most of the cases it is coming actually significant. So, that means, so this is slightly okay to go for the kind of prediction. Now, compared to linear probability models, so the logit model output will be like this. Again, the if you check the kind of sign of the particular coefficients, if whether you use linear probability model or logit model, so the sign is actually more or less same. So, okay, whatever results are coming here, this side the results are also coming in a similar way. Only thing here we have to actually, with respect to these estimates, so we have to find out the e value of these particular estimates, so that this will give you the kind of odd ratio, and the odd ratio will be finally used for the kind of prediction. So, that means, in this case it has a high impact, and this will be followed by second highest impact, and this will be followed by third highest impact. So, likewise, actually logit model can be frequently used to predict the kind of situation and to solve some of the problems where the dependent variable structure is a kind of categorical, or the kind of means typically binary in nature, it is a 0 1 kind of situation. But now, compared to actually linear probability model and binary logit model, what is happening in the case of linear probability models? So, the framework requires actually either 0 and 1. So, yes and no, but in the case of logit model, so the dependent side component requirement is log p upon 1 minus p, that is the odd ratio. So, now what is happening so while doing this kind of sampling and the kind of data analysis, be careful how you have to deal with this particular conversion. Otherwise, if you put simply 0 and 1, then the odd ratio may give you the value of 0 and infinite, which can give some kind of problem in the estimation process, which we will address with we will address here with a typical examples. In the meantime, so the third model is called as probit model, and in this case it will be followed by a normal density functions, and the particular model is like this. And if you compare this corresponding to the logit model, so it is more or less same. Again the right hand side is the z component, which is directly followed by this normal density functions, or that will be derived from the a normal distribution structures. Once you get this particular structure, then you have to connect with the as per the problem requirement or the kind of prediction requirement. So if you go through the kind of structures, so you will find in the case of let us see here, this is actually linear probability LPM structure, and then this is the kind of logistic structures, and then finally it is the kind of probit structures. So every case actually the right hand side part is more or less similar kind of structure. Only thing is in the left hand side, so the the informations will be transferred into different kind of structure. One with is simply 0-1 structure, another is with with respect to odd ratio, and third one is with respect to Z transformations. Then after that the estimation process will be more or less same. We can actually connect the probit model with a standard examples, and in this case, so here the spreadsheet shows that grade change happenings with respect to 3 different indicators. So the problem the problem structure will be like this. So the dependent variable indicates whether a student improved his grade after the new teaching method PSI has been introduced, and it will be having actually yes no kind of situation, and it is reflected by or predicted by 3 indicators. PSI indicates if a student attended courses that use in the new method, and the GPA grade point average of the students, and then TUS score of an intermediate test which shows previous knowledge of the topic. So these are the 3 variables, and through which we have to predict the grade whether it is a change after this particular new mechanism or not. So accordingly, after the estimations, so the as usual like logit model, so the probit model result is also coming similar kind of structure. So here most of the variables are coming significant impact for this grade change. Again it is with standardized framework, so the model output is coming a little bit more attractive way. And so what is happening here, all are having a positive signal to the grade change. So now so these are the various what I have done actually. So I have connected all these 3 models with the standard examples. Let me show you the typical structure through how it actually works in the real life scenario. Okay, so we start with a first linear probability model, and in this particular models, let me take this particular example, and the example is here. So family income and home ownership status. So that means we are trying to solve a problem where home ownership status is a dependent variable, and it is actually predicted with respect to family income. So that means the literary understanding is that, so if your income is very high, then you may have a ownership, if home ownership, and if your income is low, then you may not have actually a home ownership. So that is so what will you do? Will you do the predictions, or will you address this particular problem with respect to some data points. Let us say, so start with linear probability model, and y is represented here actually people having their house ownership status and their income income. So then this is a first individual, so he has no ownership status and his income is 8 lakhs per month, and again so one indicates that he has a family ownership status and his income is actually 16 lakhs. So again, so the third one is having ownership status and income is having 18 lakhs. So likewise, we have a plenty of data, and what we like to check here that whether income is a factor to justify that people having their ownership status or not. Then again you go to the data analysis package and choose the regression, and finally, so here actually you remove or clean the kind of entry, early entry, and then you first give the dependent variable structure in input, and after doing this okay, so this is actually independent variable structure. So we start with dependent variable first, and this will be give you the indication about the dependent variable. So allow up to 41, and then we go to the dependent variables, and dependent variable is again B2 to B41. So same sample size, and then we put OK. So this gives the idea about the kind of linear probability estimation. See here, and as usual it is a standard procedure. So intercept is coming negative and this is coming actually positive. So that means, so family family income is a positive factor through which income people having the ownership status, housing ownership status. So that means the way which we are actually expecting earlier. So the data is actually validating the same thing through linear probability model. So it is showing actually the relationship is positively linked, and it is statistically also highly significant, and R square is also having actually a huge kind of support, that is the fitness measures, and it is followed by F statistic, that is the ANOVA. So that means technically, so corresponding to the theoretical background and the kind of choice of the model output is actually very useful for predicting this kind of business problem, and that to come with some fantastic management decision. And this is similar kind of problem which we can actually address through other issues, that is the kind of logit model and probit models. So in the case of logit model and probit model, so our modeling structure is like this. So compared to previous ones, let us see here. So in the case of linear probability models, this is your modeling structure, so which we have already tested. But now in the case of logit, so our right hand transformation will be like this. So log of odd ratio, that is p by 1 minus p, and again in the case of probit model, so we need actually the Z transformation. So that is in the form of this particular structure. So that means compared to linear probability model, so logistic model and probit model need further kind of additional transformations before you start the estimation process. So in fact, if you use actually standard software like R, Stata, SPSS, then automatically the model is there, you can connect, the software automatically help you to give the estimation. But if you use the spreadsheet, then by default what you will do, you have to do yourself manually. But what is happening here compared to the previous case, so it is the game between 0 and 1. So go through the linear probability model, and now this is actually 0 1 0 1. So now this is actually probability p means 1 means, then 1 minus p equal to 0. So that means the odd ratio will be very complicated. So for instance, if you go to the logistic model, so this one, so when you put actually p equal to 1, and then by default 1 minus p equal to 0. So by default this will give you infinite value. So you are not in a position to estimate, but when you will put actually p equal to 0, by default this is actually 0 by 0. So log 0. So this is again actually having a kind of problem. So as a result, so what is happening, so in this kind of data set, you cannot actually directly apply logistic model and probit model. So for that, so we need actually the concept called as a group sampling. So that means we will rearrange the particular structure where X is having actually income, and that starts with 6 lakhs, 8 lakhs, 10 lakhs, 13 lakhs, 15 lakhs, and up to 40 lakhs. And then what is the group sampling concept, that we like to pick up 40 different family who is having actually 6 lakhs annual income, and out of which then we will ask everybody whether they have the ownership, housing ownership or not. then in this particular sample, out of 40 samples, so 8 are having actually yes options. So again, with respect to 8 lakhs category, so we surveyed 50 samples, and then ownership status is having 12. Likewise, 10 lakhs, then 60 family, out of which 18 families are having ownership status. So as a result, so now the p value will be the ratio between n upon n, so small n to capital N. So as a result, in this case, so what we have done here, so this is the actual data, and then from modeling we will start from here. So we first calculate the p value, and which is a ratio between small n to capital N, the number of happenings with respect to total number of cases, and as a result you will find the probability values here. Now compared to linear probability models, so logit model and probit model case, so it will be not 0 and 1 structure, but it will be in between 0 and 1 structure. You see here in the case of p value, so all these probability values are in between 0 to 1, no 0 and no 1. So if only 0 and 1, then the right choice to predict the kind of problem is through linear probability model. Otherwise you can choose here by logistic structure. The same problems, if you like to connect, then you have to go for data adjustment, like what we have done here. Now what is happening here? So after calculating p, so we need actually 1 minus p, that is the probability of failure case. So 1 minus p is the case of so whatever p will find here to here. So 1 minus p is nothing but 1 minus 1 minus p will give you the kind of failure case. So p and then 1 minus p, that is nothing but 1 minus probability of success. So this is probability of success and this is probability of failure. So that means it is the yes case and it is the no case, and that is the ratio will give you the odd ratio. So what will you do? P by 1 minus p will give you the odd ratio. Then finally we calculate actually log p by 1 minus p, log p by 1 minus p. So that means after getting the p by 1 minus p, so you calculate actually log p by 1 minus p. So now finally, so far as estimation is concerned, go to the data analysis, then again you choose regressions, and now what is happening? So you clean the kind of entry, early entry, and then here the dependent variable is this ones, that is log p by 1 minus p. So you put these options. Okay, so this is here only. So now you enter these options, then finally you give the indication about the independent variable structure, and then as usual you can actually click. So you will get the output here. So this is what actually, and the model is actually very interesting now, like the previous linear probability case, LPM model case. So it is also 90% impact, and in fact f is highly significant, and the variable income impact on the ownership is also highly statistically significant, and that too positively related. So that means compared to the previous one, logit model is much providing much better results for this particular problems, so far as prediction is concerned. Now again go to this particular structure. So we have actually same problem we can also solve through the kind of probit models, but in the case of probit models, our modeling structure is like this. So we have a model, actually probit model. So we need actually Z transformation. So that means technically, so again you go to the Excel sheet. So now we have here actually p by 1 minus p. So what will you do? So you again you go for Z transformation. So it is simply it will simply find out normal distribution sampling, and then you connect with the kind of p value here, and then you will get the kind of entry, this one. So this will give you the kind of structure. Okay. Okay. So in fact actually normal distribution function, this is so what will you do? So whatever we p by 1 minus p we have calculated here. So log of p by 1 minus p is the entry to the kind of logit model, but in the case of probit models, so we need a normal density function, and that too the kind of the normal kind of sample inverse functions, and then we have already calculated here, and again so what will you do. So, you can just once again I will show you normal sample distribution. Okay, so this ones, and then you connect with the particular sample, and then okay, this is yes, now it is coming. So, then you just scroll it. Okay, so this will be generated, and sorry, we have made the wrong entry. Okay, so corresponding to this one, so what will you do? So, our entry is actually with respect to p, we need not require actually odd ratio, that is why it is showing wrong. So, what will you do? So, you will go to the normal distribution again. So, then the entry will be with respect to probability of success only. So, that will give you the entry. Yes, now it is coming. Yes, this is the that means technically if you choose the wrong row, so it will give you wrong prediction. So, that means you see here. So, our main variable is independent variable is x, and then it will be followed by the dependent variable structure n upon n, that is the probability, that the probability of success. And for logit models, so we need actually 1 minus p, then again p by 1 minus p, and again you will find log p upon 1 minus p, and then finally the estimation process will follow log p upon 1 minus p with x. But in the case of normal probit model, so first we have to calculate the probability of success. So, that is n upon n, then we have to transfer this probability into normal density function, and for that we have already done this transformation again, and after doing this one, so this is actually generated, and then finally you go to the data analysis, and in the data analysis, so you again connect with this dependent variables. So, first you clean this previous entry, and then the dependent variables. Okay, so this is again a wrong entry. So, what will go to the, you go to the dependent variable structures. So, this way you have to enter. So, this is a dependent variable, and then you connect with independent variable. Okay, so now it is okay. So, this is how the probit model results, right. Again compared to the previous case, so the model R square is 99%, and again x is highly significant, and that too 19, and then f is highly significant. So, now what is happening? So, the problem is actually to predict people having the ownership or not with respect to their family income. So, we tested this particular problem through linear probability model, logit model, and probit model. In the case of linear probability models, we need simply the family information, whether they have ownership or not. So, it is a kind of 0-1 status, and then their income labels, and the usual estimation process is very simple, because the 0-1 is the requirement of linear probability model, but in the case of logit model, so the same sampling cannot work, because we need to calculate the odd ratio or Z transformation for logit and probability respectively. So, in that case, to get the odd ratio or the kind of probability, we have to go for group sampling, and that too we have to first fix the family income, and then with with a particular income label. So, we will check number of family, out of which how many having their ownership. Then in that context we can find out the probability, and once we get the probability, we can find out that is what the probability of success, that means they have the ownership, and then we will get failure side 1 minus p, and finally you can find out the odd ratio by doing the p by 1 minus p, and then we connect with the logit model log of p by 1 minus p with the income factors. Similarly, in the case of probit model, so we have to first calculate the probability of success by the group sampling again n by n, and then we transfer this p value with normal density function, and then we will get the Z structure, which we have already highlighted here. So, this is the entry of logistic this is the entry for a logit model, that to dependent variable, and this is the entry for the kind of probit model, and that too for dependent variable, and every case x is the kind of independent variables. And as a result, what is happening compared to 3 models, so every time there is a kind of improvement. So, this is the kind of logit model status, and then this is the kind of probit model status, and we have already discussed the linear probability model status, and with respect to this sample. So, now what is happening? So, we will just compare with logit model with the probit model, because we are using the same data structure for logit and probit model, that is the group sampling. And in this case, what is happening in the case of logit model, so it is showing actually 99, f is coming 365, and then t is coming 19.1. Now, coming to probit model, so it is actually drastically improved. Instead of f value 365, it is now moving to 372, and instead of actually t value, earlier case it was 19.11. So, now it is actually having 19.3 altogether, and again r square is more or less same, but still f value is coming high and t value is coming very high. So, that means what is actually happening? So, the same problems is you can investigate through linear probability structure, logit structure and probit structure, but there is a high degree of prediction improvement. So, that means if you compare all these 3 models, finally, probit model output is becoming more interesting and much better than compared to linear probability model and logit model. But it is not always true that every time the probit model is more attractive to solve the problem. Sometimes the probit model logit model can give better results, sometimes linear probability model can give better result, and sometimes can be probit model can give better results. So, now it is again like continuous process to solve this problem and go through continuous search process till you get the better model, and through which you can do the predictions, and then you can go for the kind of management requirement. So, that means actually what we have already discussed here. So, we have discussed dummy independent modeling, dummy dependent modeling, and various ways simple structure, multiple structure, linear model, nonlinear models, and again we have a different options. So, this itself gives enough kind of flexibility in the kind of modeling framework, that too we are highlighting here the predictive analytic structures, where the variables informations are more or less categorical. So, either through dependent and independent, but it gives some kind of different kind of structure altogether, and again it is very useful for the today's business requirement, because some of the problems behavior is always like that only. Some variables may be categorical with respect to dependent variable, and some variables again categorical with respect to independent variables. Now, having different situation and different kind of atmosphere and different kind of environment. So, what is the best suggestion is you have to pick up a particular model and test continuously with respect to a particular objective and the kind of the requirement, until you get the model which is actually better fit or best fit and free from all kind of errors, starting with multicollinearity, autocorrelation, heteroscedasticity, and as usual your fitness will be okay, and the variables, most of the variables should be statistically significant and at the higher level, and then it will give you enough exposure about the predictions, and then finally you can go for perfect management decision. And with this we will stop here. Thank you very much. Have a nice time.